In part C of the AB class distribution exercise, what we want to show is this, that if A and B lie inside the AB region for the Poisson distribution, then it necessarily implies that the QK that result from here are point probabilities in the Poisson distribution. We want to show that if A and B lie inside the AB region for the binomial distribution, then this will necessarily imply that QK are point probabilities in the binomial distribution with certain parameter values that we will establish later on, and that if they lie in the AB region for the negative binomial distribution, then the QK that we get from our recurrence relation are the point probabilities in a negative binomial distribution with certain point probabilities that we will establish later on. Now, what is the reason that we cannot just say, well, we've shown that the three distributions satisfy the AB condition, and thus we do not need to do this? Well, the reason is this. Um, Consider, for example, the equation x squared plus 1 equal to 0. No, sorry, not x squared plus 1 equal to 0. X squared minus 1 is equal to 0, or just x squared is equal to 0. Then you can say, well, 1 is a number that satisfies this relation, since 1 squared is equal to 1. So we can do the implication this way around. But the implication this way around actually is a bit different, because both 1 satisfies this, but also minus 1 satisfies it as well. So the reason why we're doing this exercise here is because we want to make sure that there are not other probability distributions that can arise when we construct the QK using A's and B's inside of these regions. Now, a thing that is pretty important to note here is which role that Q0 plays inside all of this, because the recurrence itself is established as soon as you put in the A's and B's. The place where we can kind of be insecure is, are there certain values of Q0 that will give rise to another family of distributions when I plug that value of Q0 inside here? And what we will establish later is that that question has an answer, which is no. And the reason for that is because um, we will be able to write all of the QKs in terms of Q0 and establish what Q0 must be in order for the sum of probabilities to be equal to 1. But in order for this to happen, we need to be able to express QK in terms of Q0 in some kind of way that isn't too tricky. We need to be able to express QK in terms of Q0 uh, in a way so that things don't get too ugly, if you know what I mean there. Maybe you don't. But this was just a quick motivation as to why we're looking at this, as to why the answer isn't just, well, we've kind of already done the exercise, so it's just done. So the answer for C will actually be in 3 videos. Poisson binomial, negative binomial, they will get gradually harder, each of them, and each of them will require some time to look at. But I would actually recommend that you spend some time on these, because we will be playing a little bit with how to recognize different parameters, reparametrization of distributions, and especially also how to apply the binomial theorem to reach certain results.